Hi, good afternoon. Welcome to the 2015-2016 Interdisciplinary Conference. Today we have Dr. Sanaz Dovell and Taylor Anderson, and they're going to be presenting on the antimicrobial effects of essential oils on infectious bacteria.
Hi, welcome. Okay, so keyboard in one hand and microphone in the other hand. All right, so this is a joint effort. We had two undergraduate students, Taylor Anderson and Emily Ruple, and Dr. Rowan is the other faculty member on this project. This was an 8-week-long project that we did last summer, funded through SUGAR, which is a summer undergraduate academic research program through the School of Arts and Sciences. And we wanted to know, can essential oils kill bacteria, right? So there's a problem right now. Right now, the problem is that antibiotic resistance is a major threat to public health. We find that antibiotics are being overprescribed. Patients will go visit their doctor because they're not feeling well, they have a sore throat. Doctor says you have a cold. Patient says, yeah, but my throat hurts. Can you just give me an antibiotic just in case it's bacterial? Doctor says, sure, here you go. And that happens far too often. And in fact, I even have a cousin who, if she doesn't walk out of the doctor's office with a prescription, she gets very angry. Like, why did I just waste my money going to the doctor? He didn't even give me a prescription for an antibiotic. He says, you have a cold. She says, yeah, but the antibiotic really helps. Another source, animals are routinely given antibiotics in their feed. What's the issue with that? So we see here's a cover of a Johns Hopkins publication where we have chicken with pills stuffed in the chicken instead of stuffing it with garlic or something else. Bacteria can become resistant to single component antibiotics, and that's what generally is taken as a single component antibiotic. So I have here an infographic showing that animals are given antibiotics in their feed, and all animals have bacteria in their intestines. I mean, we have bacteria in our intestine too. So bacteria have them in their intestine, they're given antibiotics. The antibiotic kills most of the bacteria, but not all of the bacteria. So the bacteria that are not killed are then the resistant ones that multiply and are resistant to the antibiotics that we currently have. So that's why we're seeing such an epidemic of MRSA, which is, antibiotic-resistant strain of staph, and we're seeing other bacteria, infectious bacteria, that are resistant to antibiotics. Antibiotics also kill the good bacteria. So we actually have very, very important bacteria in our gut flora. This is our beneficial bacteria. Most of our immune system lives there, okay? And the antibiotics will kill everything, good and bad, and it kind of messes things up. Messes up our immune system, messes up our digestion. We are, in fact, if you're mostly bacteria, did you know that? You have more bacterial cells in your body than you do human cells, okay? So it's 100 trillion friends you didn't know you had. Alternatives are needed. So, are essential oils a solution to the problem? Essential oils have been used since ancient times. So here's cypress. Cypress, you all know cypress, right? The Christmas tree, okay. So cypress is touted as good for asthma, for colds, blood capillary walls, energy, fever, ovarian cysts, all kinds of medicinal uses. There's frankincense. We've all heard the story of the three wise men. They brought frankincense, gold, and myrrh. I remember when I first heard that story, I'm like, frankincense and myrrh and gold. Why not gold and silver and some other valuable? What's frankincense and myrrh? Well, it turns out frankincense and myrrh are very valuable. So frankincense has lots of health benefits, boosts your immune system, helps wounds heal faster, cures symptoms associated with menstruation. I've even heard of people using it as anti-cancer therapies. Again, this is all hearsay, right? Myrrh, what's so good about myrrh? Myrrh can provide relief from inflammation, protects from microbial infections. It can help wounds to heal better. It's really good for the gums, apparently. Some people use it in their toothpaste. Thyme. Thyme oil, okay, a natural antibiotic, a claim that it kills 97% of breast cancer cells. I mean, again, this is all stuff I pulled off the internet. These aren't scientific studies. These are claims that people are making about these essential oils. I want to make that very clear. Eucalyptus, okay, the cute little panda bears are eating this stuff all the time, right? So eucalyptus oil has been used as decongestant for sinus infections, for arthritis. So lots of different uses, and this is not even scratching the surface of the different essential oils and the different uses that they have. Lemon oil is another one. I could go on and on forever. Well, what are essential oils? Essential oils are plant derivatives. They have been used since ancient times, as I mentioned. So here's go back. So here's a little diagram of how they're made. So basically you start out with a humongous quantity of plant compound. So let's say it's oregano oil. You start out with a big lot of oregano leaves. And you take the oregano leaves and you put it into a distilling apparatus. The distilling apparatus has water on the bottom, which is heated. The steam from the water then rises and takes the oils from the plant along with it. They enter into a condensing tube. Those of you who have had organic chemistry know condenser tubes very well. Condenser tube then converts from the steam back into the liquid form. Then we come here, this is the separator. We know that oil is less dense than water. Oil rises to the top, water at the bottom, and that's how you separate out the two. And you end up with an essential oil. So that is, in a nutshell, how essential oils are extracted. They are generally a mixture of organic compounds, which is very interesting, right? We have the single component antibiotics, but these are mixtures of organic compounds, terpenes, phenols, aldehydes, ketones, esters, alcohols, lots of different kinds of components. So, for instance, limonene here is a component found in lemon and other citrus fruits. We have carvacrol, which is found in oregano and thyme, thymol found in thyme, citronellal, you can imagine, okay, citronella oil. Vanillin is found from the vanilla bean, and cinnamaldehyde is another one found from cinnamon. Very good. All right, so all of these compounds are found from different plant extracts. Studies show and have shown, there's literature out there showing that essential oils do have antibacterial properties. Some studies claim, or actually there's a hypothesis that a lot of the antibacterial properties comes from a synergy of essential oils, and the synergy helps because it's multiple component. It's thought that it would minimize resistance, bacterial resistance, because you're kind of attacking the bacteria from different angles instead of just one angle. So it's much harder for that bacteria to develop a resistance when it's being attacked from so many different angles, right? Also, one study at least has shown that the essential oils, or at least the ones that were tested, do not harm beneficial gut flora. Okay, at least one or two strains of beneficial gut flora that have been tested. That's really exciting, right? So this shows this could be a good avenue. So we wanted to test this. So the aims of our project. Little is known about which essential oils really are antibacterial, because there is some data out there, but there are so many essential oils out there. Also, which bacterial strains are affected by the different essential oils? It's not going to kill everything, right? If you get strep throat, well, which essential oil is going to kill S. pyogenes? Dosage. How much do you take, right? You get a diagnosis of strep throat, well, now what? If you try to do straight essential oil, it could possibly burn your skin, so you have to dilute it. And a lot of things you read out there, it says diluted to a 2% solution. Well, is that enough to kill the bacteria? So we wanted to know what dosage is required to kill at least 90% of the bacteria. We did this by testing the antibacterial properties of 12 essential oils against 6 strains of bacteria. I'm going to introduce Taylor in just a minute. So these are the essential oils. We tested cypress, eucalyptus, frankincense, lemon, myrrh, thyme, oregano, cinnamon bark, rosemary, tea tree, basil, and clove bud. And we did purchase these essential oils from Mountain Rose Herbs. We did not try to distill these ourselves. We actually tried to distill oregano ourselves, but we only had 8 weeks to get this project done. Not enough time to go and gather plant materials. And the bacteria that we used, we had 3 gram positive and 3 gram negative bacteria. That's because some literature shows that essential bacteria are more or less receptive to essential oils depending on whether they're gram negative or gram positive. So we wanted a nice equal representation from each side, and these are all infectious bacteria. So I'm going to turn it over to Taylor to tell you about the first experiment.
Okay, so the first thing we wanted to do is just see if we had these in the most perfect environment possible, will they do anything at all? Because if they're not going to do anything just straight on the bacteria, then they're not going to do anything in your body, or if they're diluted down. So what we did is we did the diffusion assay. So what we did is we took some of the bacteria and we pipetted it right onto a plate, and you spread it around to make an even lawn. So then we took each of the essential oils and pipetted those onto those little tiny discs there, and then you just place them in an order all the way around, and then you put a erythromycin, which is what our control was, right in the middle of that plate, just so we could see, okay, how does it compare to antibiotics? So then we did that for every single one of the oils against all of the bacteria, put them inside of an incubator, incubated them overnight, and then took them out the next day and measured the zones of inhibition, which you just take a little ruler, measure straight across the circle that it makes, and just denote that. We did this all 3 times just to make sure that we didn't get some crazy result that wasn't ever going to happen again. So we narrowed down the 12 oils down to initially 6. So these were a couple of our plates that we did. So what you do is you just measure like across here, and that's your zone of inhibition. So as you can see, a lot of the oils did amazing things. And we were very surprised about this because no research has been done on this previously. And maybe these claims were just claims and they didn't actually have any scientific backing, but we saw they actually did kill the bacteria. And what's amazing to note is right over there, the screen one, this is Pseudomonas. Now, we don't really have an antibiotic treatment for this. And that little circle right over there, that shows that cinnamon oil prevents that from going completely, which is incredible. So we see we're actually onto something here. So what we did next is we had to see, okay, what is the concentration that we can use? Oh, we have these right here. Yeah. So the next set. We have 14 of these, and all in triplicate, so we had plates everywhere. Yes. So a couple more we had right here, like Staph aureus right there. The time just completely eradicated it completely. And we saw this consistently with several of the oils. So it's pretty broad spectrum in its entirety. So these are the measurements of all of the zones of inhibition. So we chose the best 6 in order to go on to see, okay, what is the MIC and what concentrations will they be safe at to use on your skin, because 100% will burn straight through your skin. I think it's about 5% as they recommend is about the maximum, and they're usually diluted down with a carrier oil or some type of alcohol. So we took all of these right here and we diluted them down with nutrient broth. So what the issue we had is oil and broth, they're not friends, they don't go together. So we had to figure out what is the concentration that we can put this in to where it won't come out of solution. So we did a range of 0.025% all the way up to 0.8%. So little tiny drops of oil in these huge little vials.
So one thing I want to point out, you can see that cypress only inhibited 2 of the bacteria, eucalyptus, 3 of them. Lemon only was effective against S. pyogenes, the one that causes strep throat. Myrrh was pretty effective against 3, but you can really see thyme, oregano, cinnamon, tea tree, clove bud consistently affected all of the bacteria with very large zones of inhibition, especially if you compare it with the erythromycin control. I mean, thyme, oregano, cinnamon, much better than the erythromycin control even. And so we took these essential oils in order to do the next step. Okay, so minimum inhibitory concentration is what it's called. And this is done using the broth microdilution assay. So some of you are not familiar with what this is, and I'm going to have Taylor explain what she did.
So what you do is you take all of those dilutions that I said, there was 8 of them. And what you do is across, I believe it's the next, well, we diluted them right there, and each of those little wells, it had 100 microliters of broth, 90 microliters of each of the solutions, and then 10 microliters of bacteria, because you need some broth in there just so the bacteria are able to grow. And if you're inhibiting their growth that way, then you're going to skew your results. So then I think it's the next slide. So this is how we set it up. What we do is across the top where it says BL, this is a blank. You just have plain broth in there just to eliminate that altogether. So then U is untreated, so that's where you just put broth and bacteria. If this just grows by itself, what is it going to look like? And then we have the PE and the PS. Those are our antibiotics. We have erythromycin and streptomycin, just because erythromycin works for some of the bacteria, where streptomycin works for the others. So we wanted to have a good control. And then we did all of the dilutions in 3 wells to make sure that we replicated our results. And then we also did 3 plates. So we basically did triplicates each time. So as you can see, this is just how we set it up for each time. So then the next thing we did is we put it into the incubator just overnight, and then we took it out the next day and ran it through a plate reader. And then we read the optical density, which it just shoots a light straight through each of the wells, and then we can compare that to the untreated and see if there's a difference in the number. And that's how we find out if we actually have a difference. And we did. So this point right here, this is the MIC. So this is the concentration, the minimum concentration it takes to kill 90% of the bacteria. And it's pretty incredible that we were able to find this with almost every single one of these oils in such tiny, tiny concentrations. We're talking about less than 1% in all of these, except for, I believe it was closed bud. We did have to go a little bit above 0.8%, but we'd had a little bit of a solubility issue just because these oils are so dense, and emulsifiers were skewing our results. So we had to keep that out of there. But for the most part, we were able to find the MIC of all of them.
So I want to explain what these charts are showing you. Here is 100% viability, so that is the bacteria that was untreated. So that's kind of our set standard. Then we compare each of the dilutions with the standard. So what is the growth or the optical density like compared to the untreated bacteria? And we plot that as a point. So we have here, it's not showing very well, I'm very sorry, but around 40% viability of the cells at less than 0.05%, but once you get to around 0.05%, you have almost no growth, and it stays pretty consistent, and it should stay flat like that after you've reached the minimum inhibitory concentration. There should be no more growth as you increase the concentration of bacteria or of essential oil. And so we saw these great consistent results for oregano oil. And with Pseudomonas aeruginosa, we did see on the diffusion assay that oregano oil was not that effective against Pseudomonas. Cinnamon was really effective against Pseudomonas, right? So we don't expect to see a beautiful curve like we did for the other bacteria. We do expect to see something like this where it's not as effective. And I want to show you with cinnamon, our results for the cinnamon. Because in research, nothing is ever perfect. And it's important for you to see that things don't always work out the way you want it to, okay? Right, what's going on, right? Okay, so we have our 100% viability. Poof, everything dies, right? But why is it all coming back to life as the concentration of oil increases? And the reason has to do with solubility. Okay, the oil is not soluble in broth. Now, the oregano happens to be more soluble in broth than the cinnamon. But the cinnamon, therefore, is less soluble in broth. So as we increase the concentration of the cinnamon in the broth, it wasn't mixing and able to interact with the bacteria. It just kind of sat at the top as a layer. So we were able to find the MIC for each of the bacteria for the different oils, but it wasn't always pretty like with oregano oil because of the solubility issue. So we do have a student right now whose senior research project is to solve the solubility issue, figure out what emulsifier is going to help bring the bacteria and the oils together without affecting the bacteria itself. And then repeat these experiments, make sure we do get the same MIC value with graphs that look more like the oregano oil, where it just continues after we find the MIC value. We're also able to tabulate our data and just showing, so this is percent concentration by volume. Oregano, they're all very low. Tea tree is the only one that was pretty high at 0.8%. Anytime you see a dash, that just means that the minimum inhibitory concentration is greater than 0.8%. We didn't measure anything greater than 0.8%. We saw from the diffusion assay that it did inhibit bacterial growth or was a zone of inhibition. We just didn't go above 0.8% because of our solubility issues. So oregano and cinnamon are kind of like the big winners. Same with thyme. Thyme is also pretty much a big winner across the board. Clove bud did a really good job, but not as low concentration as the first 3 oils. So in conclusion, we find that our diffusion assays show that essential oils are capable of inhibiting bacterial growth. That was pretty apparent by the very large zones of inhibition that we measured. Thyme, oregano, tea tree, clove bud, and cinnamon essential oils inhibited the growth of all of the bacteria tested with relatively large zones of inhibition, of course, with the exception of Pseudomonas, which only cinnamon inhibited. Some oils were more selective. We saw that. Some were very selective. Lemon only went after 1. Some of the other oils went after 3, but not all 6. The broth microdilution assay showed us that these oils do inhibit bacterial growth at very low concentrations. So concentrations that should not harm the body, versus 100%, and concentrations that are pretty small. So, essential oils, in our opinion, and based on our data, shows that they are promising as antibacterial agents due to their effectiveness at low concentrations, and further studies are currently being conducted to address solubility issues between the oils and the broth. And we would like to thank the School of Arts and Sciences and Dr. Alleman, who's the director of the sugar program, for funding our research, and my lovely Taylor and Emily for pretty much doing the entire research project. And Dr. Rowan, who is not able to be here. Without Dr. Rowan, I don't think any of this would have been possible at all.
Not
All right.
Thank
you.
I guess your best bet right now is strep throat. Right? Because it's, as far as like developing, taking this further into treatment.
Oh, as far as maybe application?
Uh-huh.
Yeah, maybe. I mean, skin infections also because it's topical. But your skin, it absorbs pretty much anything you put on it, especially if it's an oily substance, it'll just diffuse right through.
So what would the next step be once you kind of solve your next dilemma that you're working on? It's kind of percolating in your heads here.
Do you mean as far as a human application, or you mean as far as our next steps?
Both.
Okay. Well, our next steps would be, once we solve our solubility issue, our next step would be to see how the essential oils affect gut flora. So we do want to test this on different strains of gut flora. And I'm also interested in seeing the anti-cancer properties or potential anti-cancer properties, which is kind of a, I've been hearing a lot of anecdotal stories, but again, I want to see, is there any truth in that? As far as human applications, I don't think anybody's going to start prescribing essential oils until some human clinical trials are done, and I don't ever see that happening, because anybody can distill an essential oil in their kitchen. There's YouTube videos on them.
Yeah, as we know, for pharmacy companies, there's no money in that.
Right. So and it's very, very, very expensive to do human clinical trials. So I'm not sure what the next step would be and how we would start to apply, but some sort of clinical trial would have to be done. Any other questions?
So you kind of, when you set out, you kind of suspected that there might be certain essential oils that you would find based on what you've read about, but that changed as you did your study, it sounded like.
Mhm.
Yeah, and that's interesting.
Mm-hmm. Mm-hmm.
Are you gonna fractionate those to find out the component?
Good question. Good question. So a lot of people do that. So they'll take the individual components to try to find what is the actual compound that's killing the bacteria. So one avenue would be to fractionate them and see, is it a synergistic effect? So maybe you really need all of the components together, or is it one component in particular? The truth is, I'm not interested in doing that. The reason is because I feel like this is God's pharmacy. They're made in this way because that's how they're supposed to be used. And that's just my feeling about this. So I won't be doing that, but I know that there is a lot of research in that direction. Mm-hmm. Mm-hmm.
Are they all lipophilic? Are they all
Yes.
outside?
Mm-hmm.
Every component?
Mhm.
Okay, just curious.
Mm-hmm.
Alright, thanks.
Mm-hmm.
So you said you wanted to continue research like on like specific cell lines for kid, like would you be working with Dr. Allen? Because I know she has like breast cancer cell lines.
Yes.
Okay.
I wouldn't be doing that myself, no.
Okay.
I would definitely have to collaborate with her. But it's just something I'm interested in.
Yeah.
Yeah.
And how would- I think it might have been a different poster presentation, maybe I'm confusing it, but wasn't it you that was talking about how you also wanted to work with the cells, like or figuring out the cells in the gut?
But that was with the gut flora.
The gut flora,
Gut
that's
flora.
what it was. Yeah, seeing if it. So, are you going to continue research on like how it affects gut flora as well, or?
We'd like to.
There's a lot of different avenues it could
Yes.
go.
Yeah, I mean, there's probably like tons of different gut flora as well. So
Mhm.
it's